Alright, so today we'll be talking about factoring to solve quadratic equations. Okay, so first off I'm going to introduce the zero product property. Now, if you remember when we took a look at a graph of parabola and it crossed the x-axis, it was basically like the height of the parabola, or not the height, but the x or the y equals 0. Okay, and usually we have everything equal to y. So the zero product property is actually explaining why this actually works, that I can find a solution to a quadratic by using the roots or the zeros, everything. And this is what we're going to do. So the zero product property is if a times b is 0, then a equals 0 or b equals 0. Okay, they both can be 0, one could be 0, the other could be 0, but one of them or both has to be 0. Now, what does it have to do with what we're talking about? Okay, now if you remember, we talked about working with factoring. Okay, so if we can get something down to its basic factored form and set it equal to 0, then that means we can solve each one for x. Okay, so let's actually try it out. Alright, so let's go x squared minus 4x plus, nope, not plus, minus 32 equals 0. Okay, so let's say you're presented with this equation. Now, you could graph it, or you could actually factor it. Okay, and the two numbers that multiply to get negative 32 are negative 8 and positive 4. Okay? Alright, now that we actually have that all set up, we can actually set each part equal to 0. So x minus 8 equals 0, or x plus 4 equals 0. Okay? Alright, so all I need to do is add 8 to this side and to this side, and I get x equals 8. Okay, and then I minus 4 on this side, and thusly minus 4 on this side, and x equals negative 4. Okay. Now the key is or. Sometimes if you're looking at a real-world representation, or if you're thinking about the nature of the answers, sometimes you're going to have to eliminate one of them. So just be careful to look at the context of what the problem is you're answering. Okay. Alright, now let's say we get done factoring and we get down to something that looks kind of like this. Let me get the specific example. There we go. 5x minus 3 times, let's make this interesting, x plus 4. Okay, let's say we got down to that factoring, and you're like going, well, I know how to set up this one, because each one could be 0, so I'm going to set up the first one, x plus 4 equals 0. And some of you guys are probably recognizing, oh, if I just do the opposite sign, that's the answer. And then some people will just skip this step right here and go straight to x equals negative 4. But then they go, oh my gosh, I don't know what the heck is opposite of 5x minus 3. So to solve this problem, when you come across something that looks like this, it looks a little scary, but if you just set it equals 0, it's a simple two-step equation. So we add 3 here, we add 3 here, okay, and we get 5x equals 3. Alright, and then we divide both sides. We divide by 5. Sorry about my crooked division sign. Okay, we divide both sides by 5, and x has to equal 3/5. Okay, now obviously this is an or, so it can't be both numbers because both numbers aren't the same. Okay, but that's how we do factoring to solve quadratic equations. Okay, you set each set of parentheses equal to 0. Now, what if I get down to the end and I get x times 4 plus x parentheses equals 0. Okay, let's say I factor down to that. And you're going, well, I know what happens here. Okay, I'm going to get this part, I'm going to set it up equal to 0, and then what I'm going to do is I'm going to minus 4 to both sides. Now some of you guys are probably thinking, oh, I'm going to minus x. Well, you don't want to minus x because, well, then you get 4 equals negative x. Okay, and then you would still have to divide by negative 1 to get there. Okay, so you get x equals -4, but I don't know what to do here, Mr. Devaney. This is hard. I haven't seen this. Well, guess what? It's just as simple. That's just a term times another term, so these are two different terms. Okay, so guess what? You just set it equal to 0, and it's that simple. Okay. Now, what if I had, some people go, oh, what if I had an x squared? Is it still that simple? Yes, because guess what? X squared equals 0. Okay. And if you remember our rules, we just square root, and the square root of 0 is definitely still going to be 0. Okay, and I would still have an or in between. Alright, so don't be freaked out if you have these different situations as you're working, okay? Now let's take a look at where we have to use the AC method and get one of these, okay? Alright, now if we didn't have the -21x here, this problem would be really easy. You would just divide by 4 and then square root both sides, but we have the -21x. So what we're going to do is we're going to minus 18 from both sides and get something that looks like this. Okay, now why do we need the 0 over here? Because that's how the 0 property works. You need to have it equal to 0 for it to actually do this stuff. Okay, so now what I'm going to use is I'm going to use the AC method. Okay, we talked about this in factoring. Okay, so I'm going to have x squared minus 21x minus 72 equals 0. Okay, if you remember, the AC method is you take a times c, so that would be 4 times -18, which is -72. Okay, now I need to think of two numbers that multiply to -72, but actually add up to -21. Okay, and that number is going to be x minus 24 and x plus 3. So 3 and 24 are definitely going to be there. Now, if you remember, if I took out the 4, I have to put it back, so I'm going to put it back. And if you notice, these both share a 4. So I can go ahead and divide out of 4. And now, since I'm dividing out of 4, this actually explains why this method works so well. So this is x minus 6, and this is 4x plus 3. Okay. Now, in order to get rid of this 4, if you remember earlier when we were talking about this during the factoring flowchart, I just said get rid of it. Well, now you're going to get rid of it because you're going to divide both sides of the equation by 4. That turns this into a 1, and that turns that into a 0. So that's kind of why the method comes about so well. Okay, now, once again, once you have two numbers that multiply to get 0, just set them up equal to 0, and you're good. 4x plus 3 equals 0. Okay, so this one is just x equals 6. Okay, this one is going to be 4x equals -3, and then we're going to divide by 4, and we should get x equals -3/4. Okay, and once again, big fat or in between. Okay, so once again, the reason why we do the method of setting both equal to 0 is because if two numbers multiply give me 0, then either the first one or the second one is 0. Okay, and that's why we do it this way. All right. Now, obviously, you can graph solution to check your answer, and I highly recommend that so that you can make sure you're doing it correctly. Okay. All right. But take your time, graph your actual thing. Now, here's the cool thing: you could either graph this portion up here, or this portion right here, or this portion right here. It'll still get you the same thing. Do not graph this part in between. That's not good math to graph. Okay. So. Yeah, that you can graph this one to figure out what these two numbers are, but I don't recommend it. Just graph your solution to check your work, okay? All right, and that's it for solving quadratics by factoring. I'll talk to you later.